Hi, so in this video, we're just going to summarize the three derivatives for the three inverse hyperbolic functions. So derivatives of inverse hyperbolic functions. Okay, yeah, so again, we've got three key derivatives here. So the first one we did was differentiate the ARSINH function. And when we did this, the result we got was 1 over the square root of 1 plus x squared, like so. And this was valid for all real values of x. So the ARSINH function, so the inverse sinh function, is defined for all real values of x. And because the sinh function is a one-to-one function for all real values of x, well, that means that the ARSINH function, the inverse function, is also an injective one-to-one function. So this is valid for all real values in the real numbers. Then we differentiated the next one. So the next one we did was the ARCOSH function. So when we differentiated that, we got 1 over the square root of x squared minus 1. And this derivative was valid for all x values greater than 1. So if we think, sorry, I forgot the h there, there should be an h there, ARCOSH. So yeah, when we differentiated ARCOSH, we had to think about how we define this ARCOSH function. So if we think about a COSH function sketch, so COSH kind of looks like this. So this is y equals COSH. Clearly, COSH of x is not it's not an injective function for all real values. So we had to restrict the domain. So restrict domain to this part here. Restrict domain. And so when we did that, we reflect the graph in the y equals x line. And when we did that, we got this new ARCOSH function, which looks kind of something like that. So this is y equals ARCOSH. And we can see that ARCOSH only exists for x values greater than or equal to 1. If x was actually equal to 1, then the derivative is not going to be defined, because 1 squared take away 1 is 0, square root is 0 is 0, 1 divided by 0 is undefined. So the derivative is defined for x greater than 1, but the ARCOSH function, as a function itself, you can actually insert x equals 1 into that, and you get a value of 0 for the ARCOSH function. So that's that derivative. And we also found the derivative of the ARTANH function, so the inverse tanh function. So again, the tanh function, the ARTANH function, when we differentiated that, we got 1 over 1 minus x squared, and this was valid for all x numbers with a modulus less than 1. So all x numbers between -1 and +1. And this is because, again, of the nature of the tanh function. So the tanh function kind of looks like this. So as x tends to infinity for this tanh function, tanh actually tends to +1. So it kind of goes something like this with an asymptote of +1. And when x tends to negative infinity, as you can expect, we get an asymptote at -1. And you can actually prove this, why this is true, just by using the definition of tanh. So tanh is the same as sinh over cosh. And we know that sinh is just a half of e to the x subtract e to the negative x, and then divide that by cosh. Well, that's just half e to the x plus e to the negative x. So that's what the tanh function is. So you can actually do a bit of limit analysis. I mean, these halves cancel out. You can just do some limit analysis, and you'll see that the limit as x tends to infinity will become 1, and the limit as x tends to negative infinity will become -1. So that's that. Again, this is a one-to-one function, and because the range of this tanh function is between -1 and 1. That means the domain of the ARTANH function is going to be -1 to 1. So with this y equals ARTANH function, ARTANH of x, again, we've got these asymptotes in the domain at x equals 1 and x equals -1. And our graph is going to kind of look something like this. So just a reflection of this graph through the line y equals x. And when we do that, we get something that looks like that. So yeah, we can see the domain is between 0 and 1. So that means that this derivative is going to be valid between 0 and 1. And yeah, that's, sorry, not 0 and 1, -1 and +1, I should have said. So yeah, this function is valid between -1 and +1. And so the derivative is valid between -1 and +1. So yeah, that is just a summary of the 3 inverse hyperbolic functions and their derivatives.